Hey everyone, and welcome back to the SPT Day. This time we have a slightly different session. As you know, we're going to go for the debate session. We'll be closing this day with a debate where the topic is the same topic of the day, which is explainability and ethics. Okay, you can post your questions by pressing the button above the screen and also upvote questions from other people that you want to see asked. We'll be asking these questions according to the order of upvotes. But it's very important that you keep the questions on the topic. Okay, this is the topic of the day, and this will be our main criteria. So here with me for this session, we have all the familiar faces that you've been watching during the day. This is Alexander Jung, Pedro Saleiro, and Sara Hooker, and myself, humbly moderating the debate. Remember to keep your questions focused on the topic. Okay. Welcome all of you back. Can you all hear me? Is everything okay in the technical part? Pedro, Sara, Alex,
Yes.
the sound of life. All good. Okay, I'm gonna go for the first question of the debate, which is. Let me just take a look. Sorry, guys. So, first question. Um, so I'm just gonna ask it right through. What is the best approach to raise the awareness of the necessity for explainability, bias, and fairness in AI? What's the best way to convince people? I guess that's the question. Who wants to go first? No volunteers? Okay, I'm gonna go. Pedro, do you want to take this one first?
Okay.
Sorry to put you on the spot, but I had to.
Okay, I can try to um, give my input on this. So I think a lot have been done recently. In the first place, we have media, and media have a very important role on every time there is a story about bias in AI. We are putting this problem as a high priority issue in the society, and everyone else comes along. I think universities, uh, especially in top universities, are already catching up on this, and they have materials about these topics. Some other universities, not so much. But I think the universities also have an important role, and organizations like the SPT and the open source community, and they are very, very important. About the management and executives, it's a different story. I think it's about how companies perceive their core mission and their values they want to pursue on the products they develop. And I think explainability and transparency and fairness in AI can also be a core value proposition for companies. And when that's not the case, I think we need more regulation and more tools to engage with the community.
Does anybody want to, Sara or Alex, do you have any input here?
I mean, I think Pedro said some really interesting things. One is that let's have examples of where models are not performing the way that we want them. So we already have plenty of examples. We have examples from facial recognition systems, which perform differently on different subgroups. We have examples of bad distribution shifts. So we deploy a model for one type of data it's being trained on, but it has odd failure points. So this happens a lot in healthcare, where we train models on data that may have certain features, and the model learns to just default to those features, and it fails when it's deployed. Even things like lighting in hospitals has an impact. So if you train a model on images taken in certain lighting, and then you transfer it to a hospital that has brighter lighting, it has odd failure points. So talking about these examples motivates why people should care. I think Pedro touched on one more thing, which is there's actually a gap right now between how researchers talk about this topic and how policymakers. So we need to communicate better as researchers, and we need to talk in ways that allow policymakers to understand what's feasible and what's not. What are the difficulties of doing policy in this area, but what's also necessary to safeguard certain sensitive domains. The last part I'll talk about, which is I don't think gets mentioned as much, is that for practitioners, the biggest hurdle is practitioners don't want interpretability to be a massive second step of model building, right? We need to do a better job at creating software and tools that allow interpretability to not be this huge endeavor, like that make it part of the training process. And I think right now there's a gap there. So right now, most practitioners who want to do interpretability end up defaulting to single explanation methods. Like Lime is super popular in part because it's just got good software. And we have to think about how do we allow for other methods to also just be easy to use, and that will be a huge step in just allowing practitioners to feel more excited about interpretability as a way to understand their model, and not as, oh no, now I have to look at interpretability.
Yeah. Alex, what's your input on this? What do you think?
Yes, so I can only add to what was said about the role of media. I think the media has a key role to make people aware of how much their everyday life is already decided by machine learning. So I put it as a fun fact, but actually it's true. My job and my current partner has to some extent been chosen by machine learning, which is used in recommender systems, which decide what other profiles or job profiles I get served or offered. And if people are aware of this, then they might also be interested in questions like fairness or explanations. Why do I get this offered? And also, I would add to the media and policymakers also the role of university teachers. So I teach the big machine learning courses, which hit the almost 1,000 students per run now. And one lecture at least is about explainability and also legal aspects of machine learning, where we discuss, for example, the case of Uber cars, which caused deadly accidents, where there was a court case. And also a main driver for raising the interest in explainable AI is the GDPR, which to some extent forces businesses to give an explanation of their algorithms. Of course, it's not as strict as it could be, but to some extent, this GDPR is requesting people to understand machine learning and maybe go to a university and learn machine learning there, or get explainable methods.
It's really interesting. Like all of you guys touched on the policy / regulation aspect of explainability. But before I go there, I just have a quick question that Sara touched on, and I think it's interesting to ask, and I'm going to use a little bit of my autocratic part, which is this trade-off that we have between, for example, Sara mentioned Lime. We also have SHAP. What's the trade-off between having these libraries, these frameworks that are easy to implement, versus the results that they actually produce? Do you guys have any perspective on this? What's your input on this?
Well, I think it's interesting because both those are techniques that are, well, I mean, perhaps to start with Lime. Lime is really a local explanation method, and the focus on local explanation methods has been, in part, I mean, Alex is mentioning this, there's been a legal framework that has emphasized the right to an explanation for a single prediction, which has like driven a lot of this focus on let's explain model behavior for the single prediction, but also the computational dimensionality. So a lot of research has been on computer vision, and it's just really hard to scale estimates of feature importance. But I do hope we get better at building software and thinking of computationally efficient ways to get at relative importance, because I think it's actually there's an interesting thing with human understanding is that we like to understand the relative. It's okay to get an explanation for one instance, but I think the natural question is, how does this compare? Is this good or is this bad? And for that, I see the major hurdle for the engineering and tooling side is, how do we actually give people a better sense of how their example relates to the overall distribution of model performance in a way that's computationally feasible? And like all research problems, this is both an algorithm, but it's also a tooling problem. So often researchers sign off on their new method and then it's done, it's in a paper somewhere. So we need more engineers who are excited to think about, how does this translate to a practitioner's workflow?
I think that's a great view on this. I will have the chance now to talk again about Equitas and why we built Equitas. Mostly it was about what Sara just said. So, you know, people, they have their daily jobs, they have so many work to do, and they are used to these ML workflows. And adding more complexity, adding to increase the efforts on model development because of a secondary goal that often even management people don't really care so much about, on KPIs, on model development and evaluation. And data scientists are often really constrained about optimizing for a global performance metric. And having easy to use tools is really, really fundamental. And that's also why we built Akitas, in the sense that it was an easy way to get many metrics, because the awareness effect is not just, there are tools that often tend to stick with one definition or one way of defining a goal in terms of fairness, or they stick with one method because, for instance, Lime or SHAP are independent libraries. But it's important to have these more aggregator libraries where you have multiple methods you can try out, and you just don't stick with, oh, SHAP is so easy to use, and I always stick with SHAP, and these is non-functional requirements that come up with in the way you choose what you do. So for sure, building more software, and I think communities like this one in the open source community are really a key on making sure this gets easy to use and more people get informed.
Okay. I'm gonna change the topic a little bit back to the policy thing that we had in the beginning, which is, so all of you mentioned the policy and how important it is to have regulation. I don't know if you guys allow me to put your hands a little bit over the fire, but is there any idea that you guys already have from your experience, a specific necessity, some examples of what would you like to see happening?
I'll say, perhaps I'll start. I actually think more nuance is necessary in discussion of policy. So, for example, we've talked a lot about interpretability and fairness in this setting, and often those are seen as, let's just get those. Let's just go to the shop, purchase interpretability. It's almost seen as an objective that is a binary objective. Something is interpretable or not, something is fair or not. And this is what actually makes it very challenging from a policy perspective, because it's rarely that black and white. It's really so binary. And in fact, I think the main obstacle for policymakers is that we need, as researchers who are grappling with this field, or in fact, as Pedro is doing, who is talking to practitioners every day and is talking to data scientists, is communicating the nuance of this problem. Because I do think that there is, it's interesting. I think the biggest obstacle right now is a lack of a conversation in the middle between the people who have experience in the subject and the people who are policymakers.
Maybe Alex?
Yeah.
Yeah, so well, as I have understood, I'm not a law expert. Maybe I start to study law, might be a good investment. But in the GDPR, there's so much room for interpretation. So I'm looking for, or I'm curious to see the first big GDPR case. I'm not aware of such a case where somebody challenges the obligation of a big company for explaining their logic. So I guess we all now are anxious to wait for the first big GDPR case, and this might have a big effect on how this whole development is driven in the future. I'm an engineer by heart, so I always like to define quantities and like to measure things. This is also why I put forward this information theoretic approach, where I can measure a level of surprise by information quantities like entropies. But in the end, what really happens in the society to some extent is decided by the judge. And I don't know, I guess in Europe it's the European Court, which then decides what it means to get an explanation or a sufficient explanation.
Okay, Pedro, do you want to contribute a little?
Yeah,
Or
building on it, I think it's really nuanced, as Sara mentioned as well, and also has to do with the way regulation is written and operationalized, and because it is something that there is a high risk of being too vague or too normative.
Mhm.
And these nuanced discussions, and as Sara mentioned as well, it's about having more different people coming together and people that understand the technical part and policymakers, and try to come up with a diverse agreement on what makes sense in a given case. But regulation needs to be there, because when we talk about public sector, I think fairness should really be a must, because often people are offered services and they don't have an alternative, or at least they don't have an alternative at the same cost. And in that regard, I think governments really need to catch up and try to be more proactive and engage policymakers and the technical people on concrete cases. And then for sure, the courts, and when we have a case, that will also be a way of creating a new way of interpreting the laws.
Okay, cool. I'm gonna change the subject a little bit and go back to the questions from the audience. There's a big interest here in interpretability in, let's say, life-changing industries such as the bio or the medical sciences. I'm gonna split this question in two, and you guys can pick it up as you prefer. So one part of the question is, how do you see the importance of interpretability in these very, let's say, very intricate, very sensible areas that have a very big impact when we compare them to other industries? That's the first part. And the second part is more specific with an example, which is, if you find out, for example, in a research that's related to a medical aspect, you find out that one variable that you are looking at is more present in a certain aspect of the society. For example, let's say African American people. Do you take that into account, even though it can hinder the interpretability part? I know this was a very long question, but what's your opinion on this? The medical part versus this more sensible part of analyzing variables. Which one wants to go first?
No one wants this one.
It was hard for me to ask even, so.
No, I think this is actually an excellent question. It goes to the core, right? So one is, where do we put an emphasis on interpretability? So I would definitely say here is a great example of what motivates interpretability tools. You have a downstream task, which is very sensitive, and an incorrect prediction can cause huge impact on human welfare, which should always be the criteria of like the emphasis that you put on interpretability tools. But there's a nice twist to this question, which presumably there's already been some amount of interpretability, and it's been discovered that a subgroup I guess defined here by race, has some feature which is correlated. So there's a correlation between the race and the target variable, presumably, but there's some underlying variable which is capturing race. So this is the goal of interpretability, is just surface patterns like this. So in many ways, what's being described is we have some form of ordering tool and we've discovered this correlation, what next? And I think here it's very interesting because what next very much depends on, I would call it the two different frameworks of fairness, which in fact, there's many different. I think this is another subfield which is very fascinating right now because it's trying to codify subjective values about how we think different values in our society should be treated. So it's very nuanced. But in this case, I would say there's almost two different ideas here, which is that sometimes for subgroups, we want to actually make sure that the model treats that subgroup or learns attributes for that subgroup. An example of that is that perhaps you have a facial recognition system, which we had recently, which had far better performance, far worse performance on Black people of color than on other racial groups. Mm-hmm. In that case, the issue is the model, because that was underrepresented in the data set, has really not learned a useful representation. But there's another framework of fairness where, for example, if you have resumes that for women have certain words that have been associated that make the model learn that's a resume associated with a woman, like, for example, you list that you are part of a women tech makers club and the model learns that spurious correlation. In fact, that's not good. You don't want the model to learn that particular spurious correlation. And so in this case, it's a little nuanced and it depends upon what your objective is. Do you want, in fact, uniform performance across the subgroups? Or do you want, in fact, the model to impede performance in some way on the subgroup so it doesn't learn certain spurious correlations?
Pedro, do you want to pick it up?
Yeah, sure. I think I'm going to focus more on the fairness part because this is a topic that I think often it's hard to have these definitive answers in this type of discussions. It really depends on specific use cases, on the scoping of the project. What is the action that is going to be informed by the model? Because an unbiased model by itself doesn't say much if there is no specific action being taken with the model. So even in this case of the facial recognition, I think most of the times the huge concern was about if you use these kind of models for policing, and how are you targeting people from minorities because of the lack of good representations of the model and behaves poorly in these regions of the feature space, and in the same sense, when we think about using these types of models in healthcare, and you're providing access to a service, is more about missing people that need help, that are at risk of developing diabetes, of developing a specific disease. So in that sense, it's about what is the impact of the actions that are being informed by the model, and also don't forget the human in the loop. Because human in the loop might be overriding the predictions, and at the end, doesn't really matter if you have a fair model at the end, if the human or the doctor or the police officer is surfacing their unconscious bias in the actions they are taking. So it's more about the holistic approach of the model, but the use case in the application, and whatever requirements in terms of interpretability that might be there. So it's that I really just want to say that those kind of questions, that there is no actual right or wrong definitive answer for that.
Alex, any perspective, if you want to take this
one?
Yeah,
so for medical applications, I mean, I don't know how to look at this different from other applications. We always want if we have a framework that allows to quantify the quality of an explanation, we want optimal explanations. No matter if this is a recommendation on a streaming platform or recommending a medicine for a patient. So we always want optimal explanations. I don't know. And in the medical domain, in the end, it's some model. For example, the model is in the brain of a medical expert, of a dermatologist, and he takes a decision in the end. And we might want to have, in certain application domains, we want to have the human in the loop, which was mentioned before. And also this allows, for example, to avoid GDPR, as long as you have a human in the loop, which signs and is responsible for the decision. But even in this case, explainability might be important to engage the user of the machine learning method, like the doctor, to help him or her to understand the model. So this deep learning model, which predicts this particular medicine and then explains it. And based on the explanation, the doctor might find out, oh, this model is not trained on the right data set. Let's use a different data set. So even in this case, explainability might be the key to optimally combine the knowledge of the human expert and the number crunching devices, what the deep learning methods are.
Okay. Let me just apologize in advance a little bit for asking. I know these are very, very hard, sensible questions, but I think it's very interesting to get a perspective from three people that actually know what they're talking about, and I think it's interesting for everyone to hear, although they may be a little bit hard to answer. So thank you guys in advance for this. Let me change the topic a little bit and make it maybe easier or not. We have a question here about how do you foresee the inclusion of interpretability, explainability in automated machine learning pipelines? So a more technical question, I guess. Anybody wants to go first? Please don't make me go first. I have no idea what to answer.
I didn't see fully automated machine learning pipelines yet. So
yeah, this sounds like a question from the future. I mean, it goes back to the tooling question. So we're struggling already to do. I think there's a big question first of how to enable tooling in an easy way, and then perhaps then you have the most realistic way I could imagine automated interpretability is, in fact, techniques that try and surface more challenging examples for human in the loop inspection. And so I think that it's actually, perhaps that's an interesting form of automation, is that you have a good estimate of what is an outlier, what is atypical, that a human should definitely take a look at. Because right now with single explanation methods, if you're trying to audit an algorithm, how many single explanation methods do you have to look at? And we have large scale data sets. So we have millions of data points for most of our training regimes. And thinking about how do we surface a tractable subset, so the 10% that I estimate to be most challenging for further inspection, that's quite exciting. And that's what I would perhaps think of as interesting in terms of automating some of these checks. But for that, we need to get more computationally efficient, because most estimates that are looking across all of a data set right now are very computationally prohibitive. And so I think there's exciting opportunities there, both on an algorithm side and on a software side.
Yeah, and I think it also has to do how you encode these goals in a framework that tries to automatically find you the best configurations, let's say, or the best model. I think it's very tricky to tackle issues in which as humans are not really, didn't reach yet an understanding, a complete understanding of all the trade-offs and all the nuances, as Sara has mentioned, and jump right to fully automation. That's a huge jump. So I for sure I will expect some of these secondary characteristics to be encoded as goals in AutoML, because that's how the tech community has evolved over time. We especially machine learning, we love to optimize for a specific goal, and we love automation. But I think we should be very cautious, and maybe rather than getting a winner, it's good to maybe we can use AutoML to narrow down the search space to kind of a menu of options of models that we can build, and not just to kind of an approach of a winner takes it all.
Okay, Alex, were you going to say something? I don't know.
Yeah, so I mean, explainability, I guess, as we discuss it today, is related to a user, a human user of the machine learning method. So at some point, there is a prediction delivered to a user, and this prediction might be obtained by some AutoML method. But if the user is not present anymore, I mean, still we can talk about information theoretic quantities, but this would then be related to a certain design for AutoML methods. So it might actually be a good idea to use these explanations in this adversarial network designs. But I didn't see this yet. Yeah, so might be interesting venue to improve this model optimization or architecture optimization for deep nets. But yeah, I have not worked in this yet.
Yeah, I guess as we were saying right in the beginning of the question, this is kind of a question from the future, right? And this is such a recent area that it's really hard to answer these questions, I think, without jumping the gun a little bit. But I guess if it's not a hard question, it's not interesting to answer. I mean, having said that, let's go to a soft question a little bit, which is also, it's still interesting. It's a classic that we get, and it's very, I want to get your perspective also a little bit on it. The question is, so for someone who is a beginner in data science, which is the path that you recommend to improve in this field and become a better professional? Then we're going to go to a harder one if we have the time. So. Who wants to go? So recommendations for a beginner data scientist.
I mean, firstly, I would say congratulations on choosing data science. Good choice. I think that it depends on your end objective. So careers in data science are varied, and it depends on, do you want research to be a component of your role? Do you want to work closely to company APIs? Do you want to eventually manage a data science team? However, at the beginning of your data science career is mainly about skills acquisition. So I would definitely suggest, my main recommendation to people starting out is to build an end-to-end skills. So do try and particularly don't get boxed into only doing analytics. Really work on your end-to-end stack, because the most exciting part of developing an algorithm within, I've worked in both pure research, which I'm doing now, as well as I worked on applied. And in applied research, the most exciting thing is controlling the end-to-end process. So you're not only developing the model, but you get to deploy it. And that's really exciting. It also puts you in a different category of data scientists. So don't be scared early on to go quite technical. I think the main mistake I see, particularly at the beginning of the Korean data scientists, is to stick to analytics. And I think that it's the time where you want to broadly sample technical skills, and then you can always decide if you want to be a manager, or if you enjoy interfacing with other parts of the business to do a more pure analytics track later. So yes, learn the full deployment stack. If you want to do research, which I think is also a really exciting career choice, I would say the safest avenue is really to start doing research collaborations. So reach out to researchers, even if you're not in a PhD program, with your ideas. Often researchers are happy to externally collaborate, and start building up your portfolio of research. And also there, it's much more important to specialize, because you really want to become an expert within your chosen domain. So the biggest mistake I see there is being too general and kind of hopping from project to project. It's quite important that you choose your discipline and you focus.
Okay. I personally agree. Somebody else, Alex, do you want to take this one?
Yeah, so a good choice would be to go for a university program in machine learning or data science. But I don't know what was the question from somebody who had already a university degree.
I actually don't know. This is a completely John Doe for me, but yeah.
Yeah, even if you have already completed a university degree from a different field, I think it's a very good investment nowadays to go for a master study program. There are excellent universities all around Europe, also in Finland.
In particular, Aalto University, right, Alex?
I thought you were gonna say in Portugal, Pedro.
Yeah, no. I think our professor in the panel gave a good answer. I just want to complement with something which is, whatever thing you try, whatever analysis you are doing, whatever process you are running, just make sure you understand what you're doing. So don't simply use a tool and runs an API or something, and you don't really understand what is under the hood. So it's really important, because one day you get a point when you have high stakes decisions, or whatever you're doing has a huge impact. So it's really important that you really control and then try to understand, at least from the technical point of view, what is going on.
Okay. I think we still have around 7 minutes. I'm gonna be honest. I'm divided in between a hard question or a soft question. I don't know. Do you guys want to vote on it, or hard or soft? Okay, I'm gonna go. Maybe I go democratic here, and I'll just ask the soft question. That's the one that has the most upvotes. It's still interesting. So the question goes like: some people say that the developers will lose space for artificial intelligence models. What do you think about this for the future?
Is that the soft question?
This is the soft question.
That's
The other one involved more negative words, but it's
I see. I see. I mean, I think that so coding is an art form, right? It's a highly creative discipline. At the same time, there's a lot of code that is boilerplate. You end up copying code sometimes from one script to another because you're like, this is just code to deploy my job, and it's very repetitive code. So it's more that I think that the repetitive tasks that coders do, there's exciting work happening to try and see if we can just make that easier from our artistic point of view. We can focus on the creative parts. I don't think there's I think the idea that there's either technology that replaces or there's not is often not the right question to ask. It's how does technology interact with how humans use technology? And particular with coding, it's still so specialized and there's still so many exciting ways of expressing code. Like programmers, even my colleagues will all approach code in very different ways given the same task. And so it's proven to be a very, 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 very challenging technical task to try and emulate that. So I also think we're quite a long ways away, the same way self-driving cars was seen as just around the corner, and now it's not quite at all around the corner. So those are my 2 cents. But it does raise this interesting question of our relationship with technology. And I think currently a lot of these questions come up because we're quite anxious about technology. And I think part of that is that it feels very recent, it feels very fresh, and we've seen these historical periods before, like in the Industrial Revolution, there was a lot of anxiety about power looms developing for the first time. And I do think we'll have a more natural understanding and trust in new technology as we get more comfortable with using the tools for augmenting our own work. Yeah.
okay. Pedro, I see a smile. Do you want to jump ahead, or?
I think this is a very hard question. I think I'd say that software development is a really a key core aspect if you want to build a product. if you work on a company where you build a product, software development, in-house software development is a must. And I think we are very far away of having fully automated custom product development in the foreseeable future. So it's kind of the same kind of advice that we gave in the previous question, is about make sure that you understand how things work, that you have this kind of end-to-end empowerment of how to build things. Try to build tools, try to contribute to the open source community, and for sure you'll not have to worry about automation in your future if you really master a set of tools and set of techniques and the theory as well. So I think we have a bright future, and not so worry about fully automation in the future.
Alex?
I think that developers are one of those which have a good starting position to become machine learning, data science heroes. So I think there's absolutely no worry. To implement data science methods, you need to write code, you need to develop code. I guess there will be way more jobs than less.
Okay, I think we're all in the same boat on this one then. I'm being told that we have 4 minutes, but I cannot resist. I know that the organization is gonna punch me in the face, but I'm just gonna ask this one that's in the first place. And well, I'll just go ahead. The question is, and this will be the last one. In the case of something truly awful happening to someone, for example, losing a job, foreclosure of their home, death, due to an error of a data science model, who, in your opinion, should own up the responsibility for damages and reparations? The company, the data science team, nobody? What's your opinion? I'm reading it.
Well, I think it's the professor who taught data science in university. I think is
Okay, you're gonna go back to the. Okay, that's fair.
Well, accountability is really an open question in AI, because we might ask, who is responsible? People that collected the data, the people that in the first place define the process that in which data is an artifact from, is the data scientists that made their own choices building the pipeline, is the policymaker or the product owner that decided which model goes to production, is the regulators themselves that fail to regulate a specific area. I think it's really hard question to answer about. There has been decision making for many years, and there have been really bad outcomes due to decision making. Thinking that AI will create a perfect decision making, it's very risky, and we make sure that we have tools in place that we want to minimize the risk of error as possible. Of course, and I'll give to room to other people to answer. There is these cases about autonomous driving, but we have accidents in the roads every day in which humans are driving the cars.
Yeah.
But I think it's not all or nothing. Once again, it's a nuanced conversation, and I think one thing is for sure: insurance companies will really profit from these no man's land of accountability in AI for sure.
Yeah, I mean, I think it's great that the error is being identified, right? That's the goal of interpretability. So now you have an understanding an error is being made, and you can decide what is essentially what is the harm to welfare, which puts it in a traditional legal framework. In fact, there's a lot of work about what happens when harm has been done. So I think the difficulty is getting to that first stage of identifying the error. I actually think this question is quite salient to modern day, because I'll give you a recent case that happened in the US. So in the US, Apple released a credit card there was a lot of anecdotal evidence showing that even for a man and a woman who are residing in the same address, who had the same income, who were married, the woman was offered far lower credit lines. So New York State initiated an investigation against this new credit card, and Apple had actually outsourced creation of the credit card to HSBC. So it's already interesting, right? So the investigation then turns to auditing HSBC's. How do they put together the credit card? So this is not a strenuous, far-fetched question, but I think that it's identifying the harm that's currently the current difficult challenge. Because if an error has happened with one person, particularly the way our parametric models are deployed at scale, the likelihood is it's a subgroup of people being impacted. And articulating that, quantifying the damage, having certainty about that conclusion, that's the difficult thing. At that point, it's within a traditional framework of harm, and it's much easier to then put it in a normal legal setting and articulate it in terms of harm. But getting to the point where we can articulate with confidence that this is in fact real harm towards a subgroup is the difficult part, in my opinion. And in this question, it's been achieved. So I think it's an interesting starting point.
Okay. Alex, I'll let you take the last word.
Yeah, so I just coincidentally preparing for this panel, I looked over the report for this Uber deadly car accident, and there it was clearly argued that the reason was, or one of the reasons why this person has been hit, because the false positive rate was too high, or the algorithm tolerated a too large false or ignored too many false positives, and the reason was that otherwise the car would always stop. If there's a little piece on the street, it would immediately stop, and this would also be not safe for the customers or the passengers. So there was a high rate of tolerated false positives. But I don't know if there's a limit, if the law specifies a limit on this. I guess not, it's not possible. But additionally, in this particular case of this Uber car, there was one thing, the required test driver, or a second beta test driver, a human, was missing in that car. So I don't think it was really directly related to the AI algorithm only. So, but I guess the one who should be responsible for this is the developer of the car, of the AI of the car. So, like, if I buy a chainsaw, then I rely on the manufacturer that it's safe to use it when I use it properly.
Okay. Yeah, I guess this is unfortunately all the time we have for this session. To be honest, I would be here another 1 or 2 hours talking with you guys, and I hope it goes the same for everyone. This is super interesting for me. Honestly, I have to give you a very, very, very big thank you. These are not easy questions. This is very subjective, is very ambiguous, and I guess everyone kind of has a perspective on this. And I just have to thank you for sharing your perspective on these topics, and everyone in the organization is happy that you guys did so. Yes, so again, big thank you to Alexander, Pedro, and Sara for sharing their experiences, talking about their work, and most importantly, answering our questions. We're gonna go now. I'm being told that we're already 4 minutes over. I know I'm gonna be punched in the face for this. We're gonna go now to our closing session. So I'm gonna call Leon back to the fun. Pedro, Alex, Sara, thank you very much for this time. And well, we're just happy that we had you guys here.
Thank you.
Thank you.
Thank you very much.